Good evening. Hello and welcome to BWXT Nuclear Energy Canada's community webinar. My name is Manifa Miller. I'm the Senior Director of Corporate Affairs with BWXT Nuclear Energy Canada, and I'll be moderating the webinar tonight. Joining me is our Engineering Manager, Jordan Brown, our Director of Fuel Handling and Engineered Solutions, Brett German, and our Director of Environmental Health, Safety and Regulatory Affairs, Dave Snowpeck. Before we get started, I'd like to share a land acknowledgement to acknowledge the the nations on whose lands we operate and are gathered today. We acknowledge the land we are meeting on is the traditional territory of many nations, including the Williams Treaty First Nations, Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse nations, First Nations, Inuit, and Métis people. We also acknowledge that Peterborough is located in the traditional territory of the Mississauga people and is part of the land covered by Treaty 20, and that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. So thank you for coming together with good intention and good faith. So the purpose of our webinar tonight is to provide a presentation update and to answer questions from the community, and also to tell you more about our operations across BWXT Nuclear Energy Canada. We'll do our best to answer as many questions as we can following the presentation at the end. So if you have any questions as we go through our slide deck, please feel free to enter those questions in the comments section on the screen. We'll answer them at the end. Just so you know that even if we're not able to answer your questions tonight, you can visit the FAQ section of our website at nec.bwxt.com, where some of the answers might already be there. And if they're not, feel free to email us directly at questions@bwxt.com, and we'll be able to respond quickly. So what will we be covering today? Our agenda includes a number of really interesting topics about our operations. But first, we'll start with a safety moment. We'll then go into an overview of our operations, our role in nuclear medicine, our industry and the role BWXT plays in that industry, an overview of environment, health, and safety protocols, as well as our public information program. As I mentioned, we'll have a Q&A section at the end. And a reminder, if you have any questions as throughout the slide deck and throughout the presentation, to please enter it in the comments section on your screen. So as noted, a safety moment, and this is very timely. We'll be talking about slips and falls and how to prevent them. As you know, the nights are getting longer and the days are getting shorter, and of course, the weather is changing. So, in order to prevent slips and falls, we encourage you to wear appropriate footwear. Shoes that provide traction on snow or ice are important. As well, keep your hands free. Take smaller, shorter steps when walking for stability. Use handrails if available. Step down, not out from your vehicle. Plan ahead and watch for slippery floors inside. So about our operations. So BWXT Nuclear Energy Canada is part of the BWXT commercial operations side of our business. Our commercial operations has two segments, power and medicine, which BWXT Nuclear Energy Canada or BWXT NEC supports. As well, we'll hear more about these segments during our call. At a high level, however, on the power side, we manufacture components for nuclear reactor technology. We manufacture fuel for that technology. And as well, we provide services and operations and maintenance. On the medical side, we produce life-saving medical isotopes. We have a number of facilities across Canada, primarily in Ontario. One of those sites is in Vancouver. On this slide, you'll see the breadth and scale of our footprint, really. Canada and Vancouver is where primarily our medical business is worked out of, and the rest of our sites support the power business. Cambridge is our headquarters, with the majority of our employees, about 700 of them, out of the 1,500 employees that are across our BWXT commercial operations business. That's followed by Peterborough, with the second largest workforce for our group, as well as Toronto in the third place, and then Arnprior. So, what do we do, really? So, here is a slide that covers some of our product summary: critical components in engineering, fuel handling and engineered solutions, as well as nuclear medicine. Those last two panels is really where we're going to be focused today, as BWXT NEC supports those particular products out of their sites throughout the company. So I want to hand it over to Jordan, who will talk a little bit more about Nuclear Energy Canada and kind of our different sites there and what we do in a little bit more detail. Go ahead, Jordan.
Great. Thank you, Manifa. And thank you, everyone, for joining us. Um, uh, we're going to start talking about the fuel business, the fuel operations, and exactly we have three different that we operate out of. We're operating out of a site in Arnprior. We'll get into a bit more detail as we go in, but Arnprior looks after taking our tubes, our zirconium tubes, and manufacturing those. Toronto creates the uranium pellets. So they'll take like a uranium powder and turn it into effectively like a little ceramic pellet. That then those travel to Peterborough, and Peterborough is where we do the assembly. So fuel as a whole is approximately 500 employees across the three sites. A lot of different engineers. There's a lot of different functions and skill sets that we have. Everything from science to met lab type people. A lot of technicians, operators on the floor, management. A very significant quality team that oversees our operations. So the Iron Prior facility, that's where they make the Zirc alloy tubes, and they'll effectively take like a long, a thin aluminum tube, and that ends up core of the bundle is all the pellets that end up in that eventually. So Iron Prior manufactures those tubes; they send them to Peterborough. Next slide is about Toronto. There you go. So they'll take and they'll receive in those drums that you see in the top left a uranium powder, and we go through a variety of different processing, blending, and then like a compact press function where we're setting the overall height of the pellets, and then those pellets end up going through a very long, very hot oven where the uranium powder is effectively turned into ceramic, and the pellet as it comes out, it needs to be ground so that we can get very specific tolerances, and then go through a final inspection before it's packed up and shipped towards Peterborough. So the next slide there is the Peterborough plant. That's the overview there. You see down on the bottom right, that's the final bundle. So when we're done assembly, that's what we end up having. Next slide, if you can. Okay, so these are the components. So you'll see the Zirc tube there on the left, and we take a variety of different spacers and appendages and things that are required to manufacture the bundle appropriately, and we weld them all onto the outside of this tube. So they do a variety of different things. They keep the bundle flowing through the reactor. They also keep the spacing between each of the elements correct, so that we have the right amount of flow going from element to element. In the reactor, the bundle basically creates heat, and that heat powers turbines, which is what creates the power. So each one of these bundles is creating a tremendous amount of heat and can power your average household home, your average size home for about 100 years. So one bundle powers a home for about 100 years. There's a lot of power packed in there. So we get those Zirc tubes. We put the uranium pellets in. There's the end caps get welded on, and then you'll see the zirconium end supports. That's effectively what holds the entire bundle together. So after we've put the into those Zirc tubes, we welded the end caps on. We weld those end supports on, and the bundle is effectively held together at that point. We've got quite the quality team that's checking all the quality steps as you go through the process, and then re-inspects everything once you have a final bundle at the end. So we'll pack those bundles in big boxes and store them at our facility in Peterborough until they're ready to ship to either Darlington or Pickering sites. All right, we're gonna hand over to Brett now, who's going to talk about the fuel handling and engineering solutions business.
Thanks, Jordan. My name is Brett German. As Jordan mentioned, I'm the director of our fuel handling and engineering solutions business. Basically, we're an engineering company that looks after the automated systems that refuel the reactors at our customer sites. So, typically for the OPG Darlington nuclear power plant and the Bruce Power facility in Kincardine, this group are the original designers of the automated systems that refuel our CANDU reactors online. So, that is a unique characteristic of the Canadian reactor technology, what we refer to as the CANDU design, that it does have the ability to refuel the reactors online, and hence, reduces the downtime of our Canadian fleet. So the group that I lead is comprised of about 300 employees. We have about 150 engineers across a wide variety of engineering disciplines. So we've listed some of them here. We have a very skilled drafting and technician group, and then a variety of engineers through systems engineering. These are people that typically prescribe the requirements and ensure that we adhere to our standards and we're in compliance with our requirements. Mechanical engineers who deal with automation and piping and pressure boundary systems, software engineers who develop the code for the machines, electrical and control engineers who design our control systems. And we also do support our customers with construction. And a lot of the things that we design at the Peterborough facility, we also manufacture them on site before we deliver them. And then, as mentioned, support our customers with that installation. We do also have, as mentioned, on-site manufacturing team. We have about 50 technicians, associated QA team, et cetera, so that we can support our customers with a complete product lifecycle from the engineering, procurement, manufacturing, and construction. Back to you, Manifa.
Okay, thank you very much, Brett, and thank you, Jordan, for that overview. In the next slide, and I'll just advance it here, we'll talk about our role in nuclear medicine. So, what is nuclear medicine? Nuclear medicine is a medical specialty that uses radiopharmaceuticals to specifically image and selectively treat disease. So it's a form of personalized medicine. And you might ask, what is radiopharmaceutical? Well, it's a specialized drug containing a radioactive isotope. So BWXT, we support nuclear medicine by developing the supply of of radioisotopes. These are life-changing and life-saving medical isotopes that are needed and are in short supply across the globe. The type of products we produce, diagnostic products that are used highly penetrating gamma-emitting radiation that is detectable by cameras to image key areas. So it's that type of where the clinicians use that to identify the location of disease and organ defects. And then there's the therapeutic side, the therapeutic products that use low penetration beta or alpha emitting radioisotopes with high energy deposition to kill cancer cells. So we're working on both sides of the products for nuclear medicine and helping patients in many ways. So a lot of that work comes out of our subsidiary BWXT Medical. In 2018, BWXT acquired Nordion Medical Isotopes, that business, and with that, we gained extensive infrastructure. And since then, we've also invested heavily in the infrastructure as well. We have a highly trained, experienced, and professional group of employees and workers who are working to deliver the products that we've been promising to our suppliers or to our customers. And it's a CNSC licensed facility. So CNSC stands for Canadian Nuclear Safety Commission. So our two sites at Canada and Vancouver are licensed by this organization. We have radiopharmaceutical manufacturing capabilities at these sites and world-class nuclear transport container fleets. Before I hand it over to Brett to talk a little bit more about the technology that we have been designing and developing within the company to support nuclear medicine, I wanted to talk about a little bit on high level about how nuclear medicine is made. So to date, nuclear medicine is made in either cyclotrons, also known as particle accelerators, or research reactors. On the left on the screen, you'll see a cyclotron at Triumph at the University of British Columbia campus. And on the right, you'll see a research reactor at the University of Missouri. On that left image, I like to kind of point out that that little white speck that you see there is actually an individual, just to give you an idea of the size and the scale and scope of that particular technology. So I'll now hand it over to Brett, who'll talk about the technology that we have in development for nuclear medicine. Go ahead, Brett.
Thanks, Manifa. So one of the products that I'll highlight that was developed across the BWXT team is our molybdenum 99 program, which results in technetium 99 generators that are used at the hospital. As Manifa mentioned, they're used as a medical diagnostic tool. That isotope, technetium 99, is the most utilized isotope in the medical or the radiopharmaceutical market today. It results in about 40 million procedures worldwide annually. And the development of this project was really a pretty amazing demonstration of the skill sets across the different businesses. The targets that we see on the bottom are what we call or that's the material that actually is inserted in the reactor. That was done by our design and it is fabricated by our fuel manufacturing business. The business that I lead, the engineering side of the business, developed the system that delivers that target into the core of the reactor, where it is irradiated, and then it is removed, safely flasked, and transported to our Canada organization. And that is where our radiochemical and radiopharmaceutical lines exist, where that material is processed, and then it is transferred into these what we call generators that are then delivered to the hospitals so that the doctors can extract the technetium 99 and deploy that to our patients. So a really interesting example of how the various skill sets across BWXTs were utilized. And again, that technology was developed by the Peterborough team, fabricated right in Peterborough before being shipped to the Darlington Nuclear Power Plant and installed.
Actually, I guess, Dave, you're going to be up next. Go ahead.
Thanks, Manifa. Jordan and Brett did a great overview of the operations in both Peterborough and Toronto. And it's because our fuel operation uses uranium that our operations are licensed by the Canadian Nuclear Safety Commission, or the CNSC. And that's Canada's nuclear regulator. The CNSC conducts regulatory oversight continuously, and it's not just at relicensing periods, it's continuously over the license period. They conduct about 4 week-long on-site inspections per year. And each of these focus on one or two of the safety and control areas, such as radiation protection or conventional health and safety, environmental protection, that sort of thing. And additionally, each year, BWXT produces an annual compliance report that summarizes our performance over the course of that year. So CNSC staff review that report together with their inspections to evaluate and report on BWXT's performance to the Commission. That's done in a Commission meeting, and it's grouped together with other similar licensees. And this year, the Commission meeting will take place on December 14th and can be viewed by the public live as a webcast. Next slide. So our priority is always the health and safety of our employees, the public, and the environment. And we have a strong safety record where we're rated satisfactory by the CNSC across all 14 safety and control areas. We have strong programs that are in place that promote a robust culture of safety throughout the organization at all of our sites. And our health and safety performance has been strong, and emissions at both facilities are well within regulatory limits and remain very, very low. Next slide. So what is uranium? Uranium's an element. It's present in rocks and soil, and it's weakly radioactive. We use natural uranium and depleted uranium. We don't use enriched uranium. So what that means is that the uranium we use is mined and refined just like any other metal. It's not enriched in the isotope that causes the nuclear reaction, as is the case for power reactors in most other countries. And this is a tremendous advantage for CANDU fuel facilities because natural uranium cannot have an accidental nuclear reaction outside of the very special conditions of a CANDU reactor core. So it's an inherent safety feature that our fuel plants um, uh, differentiate compared to others around the world. And that's true for fuel plants in Canada generally. So I mentioned depleted uranium, and I want to note that this is not uranium that's been used up in a reactor. It's not spent fuel. It's just like natural uranium, except it's actually been processed to reduce the isotope that causes the nuclear chain reaction. Essentially, it's the opposite of enriched. And from a fuel facility perspective, it's the same as natural uranium. Next slide. So I mentioned that natural uranium is weakly radioactive. And so let's take a closer look at radiation in our daily lives. Um, the radiation is energy in the form of waves or particles. And it doesn't just come from nuclear power. It's all around us, and we're exposed to both natural and man-made sources of radiation daily. As a matter of fact, the natural background radiation in Canada is about 2 millisieverts per year. And people have been getting about 2 millisieverts a year for thousands and thousands of years because it comes from things that are in the rocks, in the ground, coming from space. The CNSC regulates the nuclear industry to limit the radiation that employees and members of the public receive. And we have a comprehensive radiation protection program that's guided by the principle of keeping those doses as low as reasonably achievable. So when you compare the dose received from our facility on the graphic on the left-hand side to other common sources, it's exceptionally small. So last year, the public dose from Peterborough was about 0.01 millisievert, and the dose from the Toronto operation was 0.017 millisievert. And if you compare that to some of the other items on the graphic, you can get a little bit of context for what that means. It means that this is less than what you get in a commercial flight across the country. And it's much less actually than what you get simply from living in a building that's made out of brick. Next slide. Thank you. The other element we use in Peterborough is beryllium, and it's also a metal. The graphic on the slide shows a zirconium tube, and you saw that on Jordan's presentation. And we've got a number of what we call appendages, and those are circled in red. Those are also made out of zirconium. And we coat the one surfaces of these small appendages with a thin layer of beryllium so that they can be attached to the tube. So as a result, we only use about 20 kilograms of beryllium in a year. However, beryllium is a respiratory hazard and needs to be controlled. So we do that through a defense in depth approach. The coating operation takes place in a small part of our facility by trained operators with respiratory protection. The coating area has specialized ventilation with 2 stages of filtration. And the final stage is called a HEPA filter, or a high efficiency particulate filter. And it's capable of trapping 99.97% of particles, even very small particles. The exhaust stacks are sampled 24 hours a day, 7 days a week, and the emissions from those stacks are exceptionally low. In fact, the concentration in the stack is typically about 50 times lower than the Ministry of Environment limit, which is applied offsite at the facility. Next slide. So lastly, I wanted to talk about emergency response. Like most industrial facilities and all CNSC licensees, we have an emergency response plan at both of our facilities. And we perform emergency exercises to exercise those plans routinely. And these often involve the Toronto and the Peterborough fire departments to participate. And we do that to ensure that, if there is an event at one of our facilities, that response is coordinated and that the fire department's familiar with our facility. The exercises are meant to practice and test that on-site response. And there's no scenarios identified that require public evacuation or action due to a radiological risk. And with that, Monifa, I'll send it back to you.
Great. Thank you so much, Dave. That was great. All right, before I go on, just another reminder, if you do have any questions, to please enter them into the comment section and we'll get to them at the end of the presentation. So now I want to talk a little bit more about our public information program. An important part of keeping our communities informed is really doing outreach. A lot of the outreach we do is through in-person events, as well as sending out print mailers and digital communications as well. You'll see a sampling of what we have right there on the screen. In addition to having that website, nec.bwxt.com, we have a toll-free number where community members are able to reach out to us and ask questions about our operations or share any concerns. We also like to build communications through inviting people for tours and events at our site, and also doing the outreach within the community itself. We also send out mailers, and you heard Dave talk about the emergency response drills that we hold on a regular basis. We do notify the community about this by sending out print mailers to homes in the community to inform them about this and to know what to expect. As well, we participate and are members of various community organizations such as the Peterborough Chamber of Commerce and other organizations like that to make sure that we are involved in the community, are able to hear what's happening in the community, and that we're visible and making sure and able to provide the most up-to-date and timely information to community members. Next year, I can share that we will be conducting a public attitude survey. That's also helpful for us to hear back from the community about what the concerns are and the perception, what they are about our operations as well. So the results of those surveys are posted on our website. Again, nec.bwxt.com, and that will be shared next year. So part of the outreach that we do lies under our Indigenous Relations program. We work to engage and build meaningful relationships with rights holders and other Indigenous communities in proximity to our operations. In 2017, we joined the Canadian Council for Aboriginal Business. And during that, or since that time, we have been enrolled in the Progressive Aboriginal Relations Program, seeking our certification to recognize the efforts that we've done or carried out to engage with Indigenous communities. We're in the phase 3 level of that certification. And part of that program involves us conducting regular meetings with our Progressive Aboriginal Relations Committee, which is an internal committee, to help us advance our efforts. So it includes a number of employees across our organizations who weigh in and help to drive these initiatives that we have to spread cultural awareness about Indigenous culture, and also to help us to make sure that our procurement, that our community outreach, and that our employment practices are making sure that we're inclusive of Indigenous communities as well. Finally, on this slide, I'll note that all of our leadership and the members of that committee are trained in Indigenous cultural awareness, and a number of our employees are offered the Indigenous cultural training as well. Lastly, a big part of our outreach for our communities is our community liaison committees. So this was established in 2013 in Toronto and in 2020 in Peterborough. We hold about 3 to 4 meetings a year, and really what it is, it's a forum for community members to come together to meet with us and exchange information, ask questions, learn more about our operations, and hear directly from our leadership about what we do at BWXT Nuclear Energy Canada. It's a really productive forum. We are right now actually recruiting for new members of the CLC, and I encourage anybody on the call who's interested in being a member to go to our website, download the application form, and consider applying. The deadline is December 15th, and we'll notify those successful applicants in early 2024. So that pretty much concludes our presentation, the formal side of our presentation at least. If you do have any questions, please feel free to submit them. I do have one question, which is great. It is about community engagement, so I'm happy to get that. The question is what kind of outreach we plan to do in 2024. So I did give you an overview of the outreach that we have been doing in the last year. And I kind of teased that we're hoping to do more in-person engagement in 2024. We are recruiting someone who is going to be helping on our internal side to expand the scope of our community engagement or relations program. And so that outreach means that we will be partnering, hopefully, with organizations in the communities in Peterborough and Toronto to help to make sure that community members have an opportunity to ask us questions. It might be information nights. It might be just going to different community events and sharing our information. As well as I mentioned, we do those digital communications and as well as print communications as well. Again, if you have any other ideas about how we could be better engaging our community, I encourage you to email us at questions@bwxt.com, or I'll pitch the CLC again. Please consider applying and being a member of that committee as well. So on that note, I'll give everybody a few seconds. If you have any burning questions for us today, please enter them into the comments section. I don't see anything at the moment, but I think this is a great overview of kind of what we've done. If you're not able to ask the question tonight, again, we're available at any time. Visit our website, find out where you can contact us, and we'd be happy to respond in a very timely fashion. All right. On that note, I think we'll call it a day. Thank you so much, everybody, my colleagues on the call, and everybody who was able to attend tonight. This webinar is recorded and will be posted on our website for anybody who wants to kind of refer to it and share it with members of their community as well. On that note, thank you and good evening.